In this video, you will learn about two new theorems involving triangles. The first theorem is called the no-choice theorem, and what the no-choice theorem says is that if two angles in a triangle are congruent to two angles in another triangle, then the third pair of angles must be congruent. Okay, so if we look at the diagram below, we're given that angle F is congruent to angle Q and angle G is congruent to angle R. From there, what conclusion can be made? Based on the no-choice theorem, we know that angle E must therefore be congruent to angle P. Now, where does this come from? Well, since we know that all the angles in a triangle must add to 180 degrees, if we have two sets that are congruent to each other, then that third set must be congruent in order for all the angles to add to 180 in both triangles. So that's kind of where that no-choice theorem comes from. Now, when should you use the no-choice theorem? When you're trying to prove angles congruent. And you must know that the other two pairs of angles are congruent first. So only use the no-choice theorem to prove angles congruent. You cannot use this theorem to prove triangles congruent. That's one of the biggest mistakes I see is people trying to use this theorem to prove two triangles congruent. Okay, so let's look at an example of a two-column proof where you would be required to use the no-choice theorem. So in this proof, we are given that angle 1 is congruent to angle 2. We're also given that angle 3 is congruent to angle 4, and then angle B is congruent to angle D. And we want to prove that AFCE is a parallelogram. So, remember that from last chapter, there are 5 ways to prove that a quadrilateral is a parallelogram. So based on this given information, we're going to see what we can do. So first thing I would do is just copy down the givens. Notice that angles 3 and 4 are corresponding angles. So if I highlight the transversal, which would be line AD, and then the lines that we can prove parallel are the ones that form the other side of angle 3 and 4, so AE and CF. So from there, we can say that AE is parallel to CF because if corresponding angles are congruent, then the lines are parallel. So now we have one set of sides that is parallel. Now notice that because angle 1 is congruent to angle 2 and angle B is congruent to angle D, those are two sets of angles in the two triangles. So from there, we can use our new theorem to say that angle 4 is congruent to angle 5 by the no-choice theorem. Since we had two sets of angles in the triangle already congruent, we have no choice but to say that the third pair of angles are also congruent, and you can just write no choice. Now that we know that angles 4 and 5 are congruent, we can use the transitive property to say that angles 3 and 5 are congruent. And now notice that angles 3 and 5, those are alternate interior angles. So after we say those angles congruent, now we can get the other set of lines parallel. So line EC is parallel to line AF because if alternate interior angles are congruent, then the lines are parallel. And now that we have both sets of opposite sides parallel, that's one of our reasons, or that's enough information to prove that AFCE is a parallelogram. The reason would be if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. So hopefully now you have a better idea of when to use the no choice theorem. We had to use that no choice theorem in order to get angles 3 and 5 congruent to each other. So again, remember, only use the no choice theorem when you're trying to prove the third pair of angles in a triangle congruent. Angles is the key word, not proving triangles, only proving the third pair of angles.